Our goal in this video is to learn the different parameters with which we can classify variables for which data has been collected for members of a particular population. So we proceed to page 9 and we begin with classification of data types based on the type or class. If we decide to classify variables according to types, as we illustrated in the previous video, we would look at numerical or quantitative variables versus categorical or qualitative variables. So let's strike a difference between the two of them. You see, when we talk about numerical or quantitative data or variables, it means that we can use numbers to measure or to record the values observed for that particular variable. Such variables can be cases of account balance. If we decide to collect data on the account balance of everyone in a particular class, we'll record the values using numbers that can be added and the answers will have meaning. So is weight, height, pulse rate, and number of students in your class. You observe that for each of these variables, again, just to emphasize, they can either be counted or measured. And whenever you count to arrive at a number, you have a discrete quantitative variable. Whereas if you measure in order to arrive at a number, it is called a continuous quantitative variable. Quantitative variables are also called numerical variables. On the far end of the spectrum, we have categorical or qualitative variables. These are used for either grouping or categorizing and or ranking. Take for example, if we talk about marital status, for each person, it will only categorize married, unmarried, or hair color, credit rating, good, poor, ethnic group, zip code. All of these are all examples of categorical variables because when we collect data on these categorical variables, they tend to group observations into distinct groups. To further emphasize this, let's take an example. Classify the following data as either qualitative or quantitative. The number of pairs of shoes that you own. If I have to collect data on this for every student in the class, I would definitely be recording the answers using numbers. So this will qualify as numerical or quantitative variable. What about 2, the type of car you drive? What do you think? Definitely categorical. Then, where you go on vacation, this would definitely be qualitative or categorical. Is it the Caribbean, Africa, South America? Whatever have you, this will categorize one group of response away from the other. Then, the distance from your home to the nearest grocery store, this will be recorded using numbers. And so, that will be numerical or quantitative. And then, lastly, we have the tuition for your classes. And that will be quantitative or numerical since it will be recorded using numbers. Please note that sometimes, even if you collect data as numbers, and for example, you have zip code. Let's say the zip code for this area is 45774. And you observe that in this case, if you add up 2 zip codes, the answer would make no sense. So this number, even though it is recorded as a number, it is actually a qualitative variable because the numbers, when added together, have a result that makes no sense. So there are some gray lines. And so please be watchful. You can use that rule of thumb to make that distinction. Now, sometimes too, if you have a quiz score for each student, which are recorded at the end of the term, if we convert those quiz scores to grades, then if you have reported it in that categorical sense, those original numbers that you collected Since they have been converted to grades, they are no longer seen as numerical. Rather, they are qualitative. This is just to emphasize some gray areas. Let's take some more examples on this as we proceed to page 10. And this says the table below is an example of a part of data collected on purchase records from an online music retailer. The table is also called a data table. This we mentioned earlier. So here's the question of interest to us. In the data table above, which of the variables are numerical, which are categorical? Immediately, I can see that price definitely is numerical. Why? If I add two numbers here together, the answer or the sum makes sense as the total of two online purchases. Whereas, in the case of area code, this cannot be called a numerical variable. Why is that so? Because if I add two area codes together, the number or the answer does not make any intuitive sense. And so, area code will be classified as categorical. The same applies to name, to state or country. In fact, every other variable here besides price is a categorical variable. So, it's time to look back and do a little bit of review. Considering the basic terms we learned, namely population, sample, statistic, parameter, variables, and all other fun stuff we've learned. So let's look at this example. An insurance company would like to determine the proportion of all medical doctors who have been involved in one or more malpractice lawsuits. The company selects 500 doctors at random from a professional directory and determines the number in the sample who have been involved in a malpractice lawsuit. Match the phrase with the correct term. The 500 doctors selected at random from the professional directory. This is definitely a sample drawn from the entire population. And what is that population here? The population here will be all the medical doctors who are listed in the directory. So this sample is drawn from the entire group. Then the next one talks about what the parameter could be. The parameter would be that characteristic of the population that we're interested in, and that is the proportion or fraction of all medical doctors listed in the professional directory who have been involved in one or more malpractice lawsuits. Take note, the emphasis is on the word all medical doctors. Because this applies to the entire population, it is definitely the parameter of interest. Then, next, we talk about what the statistic is in this case. If you recall, statistic refers to the information we gather from the sample that we have drawn from the population. So in this case, that would be the proportion of medical doctors in the study, not all, who have been involved in one or more malpractice lawsuits. And then the variable would be the characteristics of what was collected from each of the doctors. And that would be the number of medical doctors who have been involved in one or more malpractice lawsuits. Finally, what actual information, what raw information did you collect from each of these doctors? That would be your data. And that will be whether yes or no. This will be the raw data that was collected from each of the doctors in the study. Now, in passing, it is important to note that we discuss the variable type before we start analyzing data, because the statistical method you use in order to analyze a variable, either by itself or how it relates to another variable, depends on that type of the type of the variable. It also depends on another property of variables called the level of measurement of a variable. What is the level of measurement of a variable? We shall discuss that next. Well, before we do, we want to quickly take a quick moment of focus on numerical or quantitative variables. Recall, we said that when variables are classified according to types, we have numerical and we have categorical. What we're about to do now is to probe a little bit deeper into the types of numerical. In a nutshell, numerical variables are also called quantitative variables, whereas categorical variables are also called qualitative variables. Probing deeper into quantitative or numerical variables, some come from counting operations, e.g., the number of students in your class. You need to count to get that number. So this is an example of a discrete quantitative variable. In other words, they are count quantitative variables. In contrast, if you have to measure, say, the weights or the heights of each of the students in your class, then you are dealing with a continuous quantitative variable. So, to further deepen our understanding, let's look at this example. Determine whether the following data are continuous or discrete. The number of classes you take in a semester. I will need to count, so it is discrete. What about next, the weights of sumo wrestlers? I will need to measure, so that will be a continuous quantitative variable. The distance you drive to school. Watch out there. We actually measure distance using a speedometer. So we're measuring. And so it constitutes an example of a continuous quantitative variable. Whereas the amount of money won by a poker player, and that will be discrete, talking about the number of chips won. With that distinction made between the two types of quantitative variables, we now focus on levels of measurement. This is another parameter used to define data types. So, without any further ado, we want to make sure that anytime we set up a research question, a researcher must first note the levels of measurement. And there are four levels of measurement in data analysis, talking about the nominal level, the ordinal, the interval, and the ratio. I'd like to quickly share with you that both ordinal and nominal exist only for categorical variables only, whereas interval and ratio exist for numerical or quantitative variables only. Remember, we talked about numerical variables for which you can either count or measure, and categorical variables for which you can either group and or rank. Okay, so at the lowest level of measurement, you have nominal, followed by ordinal, followed by interval, and then lastly, at the top, you have ratio. So what is nominal? Just for grouping purposes only. Take, for instance, if you talk about high color, names, favorite foods, all we do is use each of these examples to group. That's all it does. It is used for grouping or naming a particular category. In contrast, an ordinal variable goes a step further. It groups and then it ranks. Take, for example, a survey about a product, excellent, good, and unsatisfactory. There is an internal ordering system here. You go from unsatisfactory to good to excellent, ranking it up. You have military rank and you have pay grade. These are all examples of ordinal data or variables at ordinal level of measurement. Then we proceed to interval and ratio. A very classic example of a variable at interval level of measurement is temperature. Now, when we talk about temperature, this has no true or absolute zero. What do I mean by that? See, if I say that the temperature outside is 0 degrees Fahrenheit, does that mean there is no temperature outside? I would say no. So that 0 in that case, 0 degree Fahrenheit, does not mean the usual absence of something. You know, let's draw a contrast. If I said that my account balance is $0, this is a true zero. A true zero means absence of that quantity, absence of money in my bank account. In contrast, the 0 for temperature does not mean absence of temperature. So, whenever you observe that the 0 that applies to a particular variable does not mean absence of that quantity, it means that that variable is at interval level of measurement. Whereas, if the 0 means that thing does not exist, the quantity does not exist, well, that would definitely mean that it is at ratio level of measurement. Well, I beg to apologize in this case. Exam scores here should be here, because if an exam score is 0, the person can score 0, and in this case, it does not mean that the person does not have a score. So in this case, exam scores should be at interval level of measurement. All other examples provided here are valid for ratio level of measurement. Now let's proceed to page 13, where we consider some example problems. We are to determine the level of measurement for each variable. Recall that for nominal, this is only used for grouping, and it's the weakest or lowest level of measurement. For ordinal, it is used for grouping and ordering. And for interval, distance is meaningful. That is, it has what? No zero, no absolute zero. Whereas the ratio has an absolute zero, an absolute nothingness to represent, that is represented by 0. So nation of origin, this is just used for grouping only. So it is nominal. What about movie ratings? This will be used for grouping and ordering. So a 1-star movie is not at par with a 5-star rating movie or a 5-star rated movie. So this is definitely ordinal. Then what about volume of water? Well, this is numeric. If this is numeric, it is either interval or ratio. Now, how do I decide which one it is? If it is 0 liters, it means no water. So that is an absolute or real 0. Real 0 should mean no water. So this would be at ratio level of measurement. What about year of birth of college students? If a student was born in the year 2000 and the last 2 digits of the year were recorded as 00, this 00 does not mean that the student does not have a year of birth. It is not a real 0. So this would constitute an instance of interval level of measurement. Then next, you have highest degree conferred. High school, bachelor's, master's, or doctoral. This would definitely be ordinal because it involves grouping and an order. Whereas high color would be nominal and assessed value of a house would be ratio. This will be ratio because if it is $0, then it might possibly mean that this house is mostly not existent. Then we take another example. We want to write T if the statement is true and F if the statement is false. So we have the first question. When students are asked to list their age and the percentage of their college expenses that they pay for themselves, the type of data being collected is quantitative. Quantitative, let's see. Age, this will be recorded using numbers. Percentage of college expenses that they pay, this will also be recorded using numbers. Each of those numbers can be added, and the result of 2 ages would make sense as the combined age of 2 persons, and percentages too can be added with meaningful sense. So this is quantitative data. This is true. Next question. At the end of the school term, students are asked to rate the course and instructor by indicating on a scale of 1 to 5 how well they liked the course. The data generated from this question are examples of ordinal data? Well, this is a rating or an ordering of how well you like the course. So this is definitely an example of ordinal data. This is true. Nominal data is the highest level of data. Nope. We recall nominal level of measurement is at the lowest level of measurement. So this is false. A variable, such as the length of time it takes for an employee to complete an assembly procedure at an automotive plant, is a ratio level variable. Let's consider the instance here. Length of time. If it is 0 seconds, I would argue that that person didn't do anything. So this is a real zero. A real zero means an absolute zero, an absolute presence of nothing. And so this is true. We now proceed to data types based on another parameter, time of collection. You see, if data is collected at successive points in time, let's say you collect it every month, data on total sales made at the end of every month. So for the month of January, what was the total sales made, collected at the end of the month? For February, we do the same at the end of February, at the end of March, successively at every month end. This will constitute time series data. In contrast, if we decide now that we want to answer the question, what is the average length of life of a Dell laptop? Well, and we decide to collect data on all Dell laptops right now, and we decide to analyze it right now. That will be an example of cross-sectional data, a set of data values that have been observed at a fixed point in time and analyzed. To further drive home that point, let's take an example. Which parts of this table can be considered time series and which are considered sectional? This is something to note. If we look row-wise, for each row, you will observe that for the city of Atlanta, we collected data in 2009, 2010, 2011, 2012. The same was done for Boston, Cleveland, and Denver. For each of these rows of data, we have data collected annually in yearly succession. So data values in each row constitutes an example of time series data observed and collected at successive annual points in time. In contrast, if I look only column-wise, so for this particular column, this is data collected at a fixed point in time, which is 2009, and it was collected for 4 different cities. So this data set will constitute a cross-sectional data because for each column of data, they were all collected at the fixed point in time, and that aligns with the definition of cross-sectional data. So each column in this data table represents cross-sectional data observed and collected at a fixed point in time. With that said, we come to the end of the different parameters by which we can classify data types. Next, we are going to talk in the next video about where data comes from. How do we collect data? Watch out soon.